This is question 2 in exam 3. A ball attached to a string is swirled in a vertical circle. The mass of the ball is 0.500 kilograms and the length of the string is 1.02 meters. Its speed at the top is 4.0 meters per second and at the bottom is 7.5 meters per second. Part A of the question asks, what is the gravitational force acting on the ball? So, first we draw it. And say, at any instant, the ball feels a gravitational force as it goes around the circle, always pointing down, and equal to m times g. So we put in the mass and we multiply it by g. And the result is 4.9 newtons. In part B, we're asked what is the tension in the string when the ball is at the top. Well, when the ball is at the top, it has the tension force acting down and the gravitational force. So that's the net force acting on the ball at that particular instant. So T plus F sub g is equal to mass times acceleration, or mv squared over r. So at the top, the tension is equal to mv squared over r minus F sub g. So we put in the numbers, 0.500 kilograms, and make sure we use the velocity that they give us for its speed at the top, which is 4.0 meters per second. We have to square all that. And we divide it by the length of the string, which is the radius of the circle. So that's 1.02 meters in the denominator. So we have meters squared in the numerator and meters in the denominator. So that becomes kilogram meters per second squared, or newtons. And we have to be careful to remember to subtract the tension, which I was about to forget to do. To subtract the gravitational force, which we calculate in part A. So the result is 2.94 meters. 2.94 newtons. Then in part C, we're asked to solve for the tension again, but now it's when the ball is at the bottom of its swing. So we have the tension force acting up, and we have the weight mg equal to F sub g acting down. So the sum of the forces in the y direction is the tension force minus mg is the net force equal to mass times the acceleration, v squared over r. So when it's at the bottom, it's equal to mv squared over r plus the gravitational force. And so we take whatever we got when we did this calculation before, and then we add the 4.9 newtons to get a total of 32.5 newtons. Oh, I made a mistake. And I made a mistake that some of you made. We have to put the velocity that it had at the bottom, which is 7.5. And when we do that and add and do the calculation, we'll get 32.5 newtons. And that concludes this video.